Okay, now it's running. So welcome to November meetup of not just Java Nashville user groups. Today it's very much Java indeed. Pasha is our guest, and he's from Bellsoft, and you might know Bellsoft as producers of Liberica, one of the most popular JDK distributions out there, and something that we all use, love, and definitely recommend for you as well. Your hosts, Kate, Phil, Baruch here, and thank you Gradle for providing t-shirts and stickers and a bunch of other swag. Thank you Java Community Process for their swag. Thank you Plus Park Collective. This is this place, and it's a co-working space that was very gracious to host us today. Justin, do you want to say a couple of words? Yeah.
This is an office building that was built in 1970 and still very much looks like it. We're trying to make it more modernized, targeted towards remote workers, small business and entrepreneurs. So any feedback or suggestions that you have are more than welcome. You can either talk to me directly or email hello@plusparkcollective with anything that you loved, anything that you want changed, or anything that you think would elevate the space.
So basically you have rooms that people can rent either individually or small companies and this kind of stuff?
Yep.
All right. So,
thank you so much.
Yep, here we have it. Thank you. Thank you for hosting us on such a short notice. O'Reilly still provides us tons of super awesome books, and by obviously the number of people here, everybody get a book, which is pretty awesome, pretty sweet.
Sounds like a song.
Right?
Everybody gets a book.
All right. And JetBrains provides licenses. If some of you, for some reason, still don't have a license provided by the meetup, we will be happy to give you. Otherwise, we'll start losing them as they are going to disappear. Those two on November 29th.
Yes.
So yeah, I mean, use it or lose it. It's okay. Okay, so Gradle, that's the last meetup that they sponsor. We still have their swag that will help us running through whatever meetups we want to do, but unfortunately they won't be able to pay for speakers to fly them here. And also considering how many people are coming, we wanted to ask you what you want to do next. I will ask the same question on Meetup, so it will go by the email to the 1,000 people that we have in Meetup that never showed up, and I will ask them why and what would they be interested in. And obviously your feedback is also super important. If we want to pivot, we want to do something else. Yeah, so up for discussion. We have some time until our next one. We'll skip December for holidays, obviously. And then hopefully by the time we need to look for like speaker and what's not in January, we will have a better direction. And with that,
thank you.
Maybe our last Java speaker, hopefully not, but maybe.
Well, I can speak not only Java.
Here you go. Maybe we'll have you in a different capacity.
Yeah, like I'll be in Atlanta again in March because of Nexus, not so far away.
Yeah, so maybe by March we'll have some other ideas of what we want to do.
Absolutely.
Yep.
Let's talk. Yeah, so it's probably the nerdiest presentation you have ever seen.
Maybe.
It's not even slides.
We had Venkat, so.
Okay, but he types. It's still a presentation, it's just not slides.
Okay.
So you probably know the topic. Is it readable? Yeah. Cool.
Do we want to turn more lights off?
That's what I asked him.
I think that will make it even better. And I think those are dimmers. 70s.
Nice. Okay, now it's suddenly readable.
Perfect. All right. So
I like it.
We can do this.
Well, still a little bit distorted on the edges, but
no,
much
but,
more
yeah. Did you try the focus?
I tried. I think it's in its perfect state right now.
Okay, I won't mess with it. Yeah, go for it.
At least in the center of the.
Okay. All right. No, it's good, I think.
Well, it's probably readable. Well,
Yeah.
we'll see. As you already see, I'm a geek and I'm a developer advocate at Bellsoft, and I will talk about Bellsoft a little bit later. Thanks, Baruch, for introduction. I will probably add a couple more points on top of it. Most of my career, I've been a JVM developer. I'm still a JVM developer. I use Java and Kotlin, but my background is crazy. I actually used Clojure, Scala, and Ceylon. Who knows Ceylon? Yeah, well.
I know what Ceylon is.
Yeah, so did you try it?
God, no.
It was a toy language. Well, it wasn't toy, but
It was supposed to be the next Java.
Yeah, it was supposed to be next Java. It was the language introduced by Gavin King, creator of Hibernate. Is like a lot of people believe in Gavin King, including himself. It didn't work out. It wasn't compatible with Java. It died. DevOps is not a person, as you know, but I actually could be. It's what Baruch usually says, because my career had crazy, was a crazy ride, including ops, support, development, engineering management, and so on. Yeah, I'm a long time in Linux user, so that's why everything is in terminal. And yeah, I use Arch. If life gives me a terminal, I have to make at least one presentation in it. I promised to tell something about Bellsoft. We are among 5 most popular distributions of GTK. We were created in 2017, so only 7 years ago, to support ARM32 builds of OpenGDK. Oracle wasn't interested, but there were clients who were interested, and we were like, okay, let's do it. We contribute to OpenGDK a lot. For example, Alpine support for OpenGDK is created by Bellsoft. We have our custom garbage collector for GraalVM native image, GraalVM for community version. Community version from Oracle has only serial GC. We have introduced parallel GC. I'm trying to say that we kind of know our stuff. We have several big clients, and we are one of 2 distributions that support CRaC. We'll talk about CRaC during this talk, obviously. Yeah, also if you use Spring, who uses Spring here? Some of you. Nice. We are officially recommended by Spring, and if you build a Docker image from the plugin, either Maven or Gradle plugin, it will use our runtime inside. So it's kind of, Spring is what we do. Now let's talk about snapshots in general. Why do we need them? Ideas? Okay. We need them because Java is slow. It's obviously not true, but applications actually are sometimes slow. This is how your ops will see the Spring application startup in the Kubernetes logs. For your ops person, it will start in hours. Let's just make a simple test run. It actually starts up the application right now. It's not a GIF or something. So yeah, I was very close. I just called Java jar Spring Path Clinic, not the latest one, but close to it. And it took 5 seconds to start up. Application is very simple. It kind of contains, 20 classes or so. Some of them are entities, so essentially just Apogee classes with some annotation. It takes a lot of time because Hibernate needs to find all these entities. Hikari data source should initialize and so on. And again, this very small application. What will happen to bigger ones? Once I worked on a code base that used 20 minutes to start up. Imagine that we can cut it to, milliseconds, tens of milliseconds. It sounds, as I was said at one of my presentations, sounds too good to be true. But we will try to prove it otherwise. And it's not only about Java applications, which start slowly. A lot of desktop applications actually do the same, non-Java ones. And to tackle this problem, there is a project which is called CRiU. It's a Linux-only project. CRiU stands for Checkpoint Restore in Userspace. And the idea is very simple. When you run any process, you can snapshot its whole memory, dump it to your hard drive, and then restore from a hard drive. And it actually works, which is very surprising. So let's look at this very simple example. Let's say we have this bash script, just a loop from 1 to 10,000, which does very simple thing. It prints current counter and sleeps for 1 second. If we want to create a CRiU snapshot of it, we will do a very simple thing. We will run this script, wait for some time, I don't know, 5, 10 seconds, whatever we need. Then we will call a command like CRiU --- shell job dump. Then we have to pass PID of our running program. It's luckily there is a command PIDOF in Linux, which works like just pass it executable path, and it will return PID to you, PID to you. And then to restore it, we can just call restore. Let's actually try to do it. Give me a sec. I have it somewhere here. Right. Let me show you the. Oh, I have a bunch of garbage here. Let's delete it all. We need to delete all the image files and all the stats files. And now it should be more or less clean. Yes. As I promised, the same shell file, just my.sh. Oops. Let's run it. Okay, it's running. Let's create a new tab, and we need to call CRiU with sudo because it requires some capabilities. Shell job dump. Okay. -- shell job dump -t, and then we need PIDOF of our application. PIDOF -x my.sh. Requires my password, obviously. Gives us a couple of warnings. It says that we do not have CUDA checkpoint, which would be useful if the application would use CUDA. It also has something else. Let's look at logs of the application. What happened to it? It was killed. And you can see that it was killed after 45 seconds of execution. And this small cross, which is almost unseeable, it actually says that it's not zero code finish of our job, which is fine, actually, because it's not a clean exit of the application. Clean exit is only one state when the application says itself, I am finished my job. This is completely different scenario. Now let's try to restore it. Oh yeah, let's look at all files we have. We have some of them are bigger pages files. It's essentially a memory. Some of them are map of calls from core to core, file system, and so on and so on. Like a lot of magic stuff in here. Yeah. So the CRiU shell job restore. And it again gives us a couple of warnings about, this time not only about CUDA, but also about AMD. If we would use AMD GPU, we would need an AMD GPU plugin. We do not have it, and I do not have an AMD GPU. And every time when application starts, it starts from 46 immediately, which tells us what? The state of application is saved, and we continue execution from the same state. It will obviously happen every time. Otherwise, it wouldn't be in this demo. And I like it. It's like perfect. But it doesn't always work. So let me start another application. For example, I have a custom terminal called WestTerm. Let's try to dump it, actually. We need to find its PID. It will be something like this. And now we can shell job dump -t PID of our WestTerm, and it doesn't work. And the issue is, it doesn't even tell us what the actual problem is and how can we fix it. Can't open map file link something something. I don't know what it is. I don't know how to fix it. Maybe if it's WestTerm is not a shell job, so maybe I should remove it. No, actually nothing changes. Also, I like this comment, unknown sheet 600. Well, unknown sheet, it's true, yeah. This is exactly how I see it. And this is the issue with CRiU. It's like a Linux project which is supposed to work for Linux, and it works, but only for very, very small subset of applications. I wasn't able to suspend my browser, which would be interesting actually, to quickly restore its state. I wasn't able to suspend my terminal. I wasn't able to suspend my Slack client. They all have something in them which prevents CRiU to work correctly on them. And of course, I cannot suspend any Java application. But this talk wouldn't be a thing, right? This talk is about CRaCing Java snapshot. And the thing is, there is an open JDK project called CRaC. CRaC stands for Coordinated Restore at Checkpoint, which is it is actually based on CRiU, same idea. And when you download a JDK flavor or Java flavor or JRE flavor with CRaC included, you will see CRiU binary in it. I should say it only works on right Linuxes. Like it doesn't mean on my machine, for example, CRaC doesn't work even though it's Linux. So I do all my demos in Docker. On mainstream Linuxes, it will most probably work. But in Docker, I use our own Alpakita Linux. Well, there it's just guaranteed to work because we test our Java on our Linux and we test that everything is working correctly. The idea of CRaC is very simple. Let's just modify the Java virtual machine in a way that it will understand all the CRaC calls. Like, if you have file output stream, it will close file output stream before you make a snapshot, at least theoretically, and it will reopen it when you restore from snapshot. Actually, for files, it doesn't work this way because it's impossible to guarantee that when you restore this, when you restore from a snapshot, file is at the same place. It's possible to do for something, but not for everything. That's why Spring has its own support for CRaC. We'll talk about it a little bit later. So, yeah, here will be a lot of disclaimers. First, CRaC is not a canonical part of JDK. It means that if you download Timorin, for example, there won't be CRaC. If you download vanilla OpenJDK from openjdk.org, there won't be CRaC. Some JDKs included, for example, Liberic JDK, here's the download link, and also I should say that CRaC is first implemented by Azul. They also are a major vendor of JDK. We support our own fork. We backport a lot of things. We made some changes in our Liberic JDK, but we use their code base as a base. Also, I say that CRaC is nice, but I do not say that there are no other solutions. Like, for example, native image actually solves the very same issue. Native image also allows you to start up your application faster. But I say that developer experience and productivity are good with CRaC. And actually, I say that native image has huge issues with it. When you build a native image of your application, the build itself can take tens of minutes for bigger applications. Some of applications won't even build because you won't have enough memory. If you'll try to build IntelliJ IDEA with native image, it won't build. Any native image, our native image, Oracle's native image, just not enough memory. Application is just too huge. I had this talk with Wirtinger, and he told me that, well, they are trying to improve it, but they are not there yet. At some point, they will implement what they call layers, and it's like you can build any library to its own small native image and then link them all together. At this point, maybe native image will be a perfect solution for all the problems. But currently, it's not. I'm trying not to hide downsides of CRaC. I will talk about them during this talk. But if you notice something, if you have questions, please ask. I actually can forget something. When we're talking about CRaC, not all builds, not all builds of Library GTK have CRaC built in, because CRaC actually makes GTK bigger. It has some additional information in GTK, a lot of it actually. So, yeah, using CRaC is definitely not about saving space on your hard drive. It is something different. It's about solving the real life issue that we need to restore our application. Let's look at this. Is it readable?
Yep.
Cool. So the code is very simple. We have like start time. We have this for loop for our range from 1 to 100, essentially what we had in that bash script. Then we have thread sleep for 1 second, and we print counter value, and we print how much time passed from the previous iteration of our loop. The goal is kind of obvious, right? We just want to measure, we just want to check if our CRaC works on a very simple application. Docker file for this application will look something like this. Please take note, it's not what you do in production. Like, I use JDK as a base image, which is probably a bad idea for running in production. I also compile my Java file right there in Docker file. But what we are interested in is this small additional argument. Minus XX CRaC checkpoint 2 equals up / checkpoint. This is not what you usually see. It's a part of CRaC. It is there only if your JDK supports CRaC. It kind of speaks for itself, right? It says that the CRaC checkpoint will be saved to this particular directory, even if it doesn't exist. And yeah, I just called my build right inside slides, and that's the reason why I use terminal to make this presentation. It's very CLI heavy, so I'm doing half of my work right on slides. Now, how will I launch my CRaC application, and how will I actually create a snapshot? But first, let me show you something. I have this command called dive, and it actually can look into images. Okay, it's slightly distorted, and so you can see the structure of the whole thing. First it's our base image, then we add our Java file. You can see on the right in green that it's app example Java, and then when I compile my example Java, there is one new class, example.class. Okay. This is how I run my application for it to be later correct. I use this complicated call, who understands everything written in the Docker run. Baruch understands. Okay, let me explain. Docker run is kind of obvious, right? Then we add two capabilities, cap csp trace and cap checkpoint restore, which is very interesting. We need cap csp trace. Well, we need to process the whole process tree. Sometimes our process creates additional processes. We need to know about them. Also, this capability, and I cite the documentation, also says transfer data to or from the memory of arbitrary processes. Usually, Linux doesn't allow this shit. Like, you cannot just go and read a memory of a foreign process. You should have special permission. When you will run it with this permission, your system administrators or whatever, ops people, platform engineers, will start asking questions. I almost promise, like, why do you need it? Do you really need it? And you will have to explain. It means that you cannot just use CRaC. You should have business need to use CRaC, because it's potentially dangerous when you run something with this permission. You can read from arbitrary process. Imagine there is another container with some credentials in it. You can actually read these credentials when you have cap CSP trace permission. So they will probably look very carefully at what you're doing. The second one, cap checkpoint restore, well, somehow there is a special cap for this, special capability for this. It allows to do a couple of things. Update process kernel and last PID, because when you recreate process, it probably cannot have the same PID as it had when it was launched the last time, because this PID can be occupied, or, as in my Linux, you just cannot create processes with same PID which already existed. Sometimes when my machine logs for a long time, PIDs are like in 7 numbers. Yeah, I'm not joking. Also, it allows to read contents of proc PID map files, just to be able to read all the file handles. Well, -d is kind of speaks for itself. We just detach from this process. We are not really interested in it. And then pre-CRaC is just a name of container I will run. Take a note, I do not use --rm here, because I actually don't need this container to be deleted when it stops. As you remember, when I create a checkpoint, the process is killed. For Docker, it means that process execution is stopped. And if I pass --rm there, Docker will automatically delete the container. It's not the behavior we need, and not the behavior we actually appreciate. Here's how I will use it. I will create a variable ID, and this ID will store the hash code of our container, hash sum of our container. Then the second line is kind of interesting. Who knows JCMD? JCMD is a magic command from JDK that allows us to do anything to our process. Attach agents during runtime, dump heap dumps, dump thread dumps, whatever. When there is CRaC in our application, in our JDK, there is one additional command that is supported, which is called jdk.checkpoint. 129 is a magic number. I just remember it. When I run anything inside our base image, which is Liberica, the running application will always have a PID 129. At least if you're running an application in a simple way, like Java -jar something. And then the third line, Docker commit. This is why we can't remove the container actually, because when there is a checkpoint inside the container, we need to somehow save it. Docker commit allows us to save a stopped container to a new image and use this image. This is a thing very important for your CI/CD pipeline. You can create a container and you can create an image. Then you can delete the container if you need, and then you push the image to your artifact repository. Yeah, let's actually do some demos. I have this, give me a second. Yeah, so the same application I showed you, example, is just counter. Let's call docker build -t pre-CRaC dot Yep, should be there. Oh, I did it from the presentation and I already forgot about it. Now, our stuff with ID equals. Let's look at logs, just to be sure that it works. -f $ID. Kind of works. Docker exec. Let's make a checkpoint and let's look at logs again. There is one interesting log, log entry at the very end, starting checkpoint. Well, also logger container info, not that interesting, starts in checkpoint and then nothing. This is all right. Then we need to commit our container. Let's dive into our container now. It was 3 layers, now it's 4 layers. Here we, on the 3rd layer, as the last time, we see that it's just a compiled class. On the 4th layer, we see that it's kind of huge. It's 28 megabytes for a very small application. It's just one class. Well, there are some streams involved, but nothing too interesting. And, well, it just tells us that JVM is big. Like, we need to dump a lot of data about JVM. Now, let's try to launch our application, our newly created container. Docker run, -it, post-CRaC. Oops, it doesn't work. It doesn't work because I forgot to replace entry point, and I didn't show you that I have to. That's why I forgot myself. This is how you're supposed to run a newly created container. You obviously can just write another Docker file and say that from this post-CRaC and overwrite entry point there is just an easy way to do it in your CLI. Yeah, every time it starts, it hopefully starts from 17. But if you look at past, it changes every time, which is unexpected behavior. It is how it should work. Because actually a lot of time passed since our last iteration before 17, and every time it changes, obviously. Yep. Okay. So at this point, you know basics. You know how it works. You know how it works for simple applications without Spring, without actually any interesting logics. But the good thing is, Spring Boot supports CRaC out of the box since version 3.2. I have a small demo here. I have this. Let me show you, actually. So it's not that. I need to reopen my Spring Pet Clinic.
So here, does the application know that it is starting from a snapshot?
Sorry?
Does the application know that it has started from...
Do you mean the last demo?
Yeah.
Yes, it starts from snapshot.
No, I mean, if I'm an application,
Yes.
will I know that I'm starting from a snapshot?
Will you?
If application itself, they know that it's using not original image, it's going to be used for snapshot.
Oh, I didn't show you. So yeah, we actually didn't explain this part.
Can do some cleanup or some...
Yes, it can. It can. It will talk about it. For this application, very small, it's not important, but it will be important in the next parts of presentation. I also didn't show you, I overwrite entry point to Java, but I forgot to tell that I add one more important argument, CRaC restore from, which is obviously the same directory. And you can use a different JRE or different JDK than with what, like you can't use Azul to create create a checkpoint, and then use liberic to restore a checkpoint. It should be identical flavor of identical JTK, which is usually fine. You usually don't care too much about this stuff, but just a thing to know. So yeah, I have this Spring Path Cleaning application. It's, you see how small it is? It's some classes. Let's launch it at first. And for that we need to build it, and I need to go to the Spring Path Cleaning. For Spring to work with CRaC, we need to add one more dependency, and this one, or CRaC. Anything starting from 1.4.0 will do. Actually, nothing serious changed since 1.4.0. Spring itself knows when CRaC dependency is there and does all the magic under the hood, as Spring always does. So let's build our application. Nope. Like this. Take some time. Yeah, this is an interesting part. Actually, Spring performs the test run of the application to have more information about what will happen at runtime to initialize less. Now we can build the Docker. With what? Wow, this is an interesting one. Give me a sec. Oh, yeah, right. -f. I have multiple Docker files here for different experiments. Yeah, it's there. Now our magic with running application. Let's check if it's working. It's working. I mean, images here, owners here. Let's look into logs of our thing. Docker logs. $ID. I'm looking for something useful about startup time because I see that completed initialization. Yeah, here is it. Here you go. Path cleaning application, which is only 5 classes, took almost 20 classes, took almost 6 seconds to start up. Now the same thing with Docker, with checkpointed it, like this. Let's look into logs. Actually, nothing interesting. Yeah, starting checkpoint is here. And then Hikari says, yeah, I'm fine, I'm evicting all the connections.
So essentially, is it closing all the existing connections?
Yes, of course. It closes all the connections managed by Spring. Okay. So if you have data source connection which is managed by Spring, it will be closed. Otherwise, we'll talk about it a little bit later. But you ask a lot of interesting questions. This is very cool. Now we need to commit it. And now we rerun with our entry point, with our custom entry point, and this is all. Like, it was starting for 6 seconds. Now it starts for 27 seconds, including Hikari, which says something not too useful. But applications should work too, right? Let's check. Kind of works. It seems so. I mean, also, it's important to understand that it was just a simple run of an application. Imagine that you not just start up your application, you actually run your load test suite on it. And it optimizes all the hot paths in your application. They also will be saved to a snapshot. So it's not just a fast startup. It's probably the optimal performance you can achieve. And if you even run several tests, it will improve performance. It will remove all the warm up of the JIT, at least most part of it. as somebody told me it's just too good to be true. And of course, there are catches. You guessed it, there are issues. Let's try to break it. I have my small project here, which does a very simple thing. It's essentially one file. Who knows what SSE is? Servers and events. Wikipedia has this very nice API which returns you all the recent changes. Let's look at it real quick. We'll do something like curl and then this. Yeah, so there are a lot of changes in Wikipedia. Every second, probably multiple. I don't even know. This is how it looks. Continuous stream of data. It will never end until Wikipedia fails. And I have a very small controller here that reads data from the stream. This is a part of Reactor, web client.create. We create a client for SSE stream. Then I have my own field, last data. I just want to put the last edit which was sent over the SSE stream. Then it's just a magic of Reactor project, client.get.retrieve. We convert any data to string. We do not care about its structure at this point. We don't need any JSON parsing and so on. And every time we get a new item, we put it into last data. Please do not write such a code in production. It's probably a bad idea. It should be atomic reference or something like that. We just need it for demonstration purposes. Then, on class construction, I initialize the data stream, initialize reading, and I have only one very small endpoint, which is called last data, absolutely not REST style, and I do not care about REST at this point, which just returns us a string. Let's test it quickly. First we need to build it, and I don't care about tests. Please use tests when you are not in presentations. Hopefully it will build. Yep. Now Docker build, and I don't need this part, I think. Yes, I'm fine. Then I'll restart the container. Let's call our thing, localhost 8081/last data. Currently it's cluebot3 something. Category images from Geograph Britain. Translations. Well, so it's different data every time. Now the usual drill. We need to create a checkpoint of it. Commit it. Then Docker entry point stuff. It starts very fast, 36 milliseconds, faster than Pet Clinic. Yay! Let's try to request it. Oops, wrong thing. Last data. Something file 2017. And every time I request it, it's the same data. Why?
Did the client fail? Did what client fail?
Well, it didn't fail actually. We stopped it. Well, CRaC stopped it. But it doesn't know how to recover, which is an issue. So we need to fix it somehow. And this is what you asked about custom resources. Let's do it this way. We need a, let's call it subscription variable. Let's put this subscription into a field. Property declaration. Put it here. It will equal null, which is fine, I think. What's wrong? Yeah, because it's val, should be obviously var. Now, there is one important interface in CRaC, and it's called resource. Or CRaC resource, which forces us to implement a couple of functions before checkpoint and after checkpoint. Sorry, before checkpoint and after restore. I hope that names speak for themselves. How do we implement them? Obviously, on before checkpoint, we should dispose our subscription, and after restore, we should somehow restore it. How do I do it? No, sorry. Of course, it's should be done another way. It will be something like that. Subscription equals data flux subscribe. This is not all, sadly. Well, I mean, CRaC doesn't know about this interface. CRaC doesn't do any class path scanning. It means that in our init block, we need to say CRaC, please know about us. CRaC has one interesting class called core, if I remember correctly. Yes, I remember correctly. It has a global context, and we should register this, which is okay. Well, it should do the magic. Hopefully. Did I do everything? I think so. Let's try to build it. What? I see. Wrong tab. Gradle build. Should be faster this time, right? Please. Yeah. Docker build. Docker run. Checkpoint. Sorry. If we look at logs of our ID, it will look actually creepy. There is a huge stack trace. This is because it's impossible to close our connection cleanly. The data is always flowing, and we should just interrupt it. But we see that this happened after starting checkpoint. Hopefully it will work. Let's try. Started very fast. Well, not very, it was 83 milliseconds. Should be fast on your servers, I hope. File to... Doesn't work. Interesting. I think I forgot something. What could I forgot? Oh, I forgot to commit it. I see. Let's try it now. Yeah, now it updates again. Do not forget anything. I have a bash file actually. Give me a sec. Where was it? Build me. It's very simple. Oh no, it's not this one. Build.sh. It just builds our application, then builds Docker image, that does all the same things. Then it sleeps for 5 seconds to give our application to start up. Obviously, in your CI, you would prefer to not sleep for 5 seconds, but to run some tests for some time, just to be sure everything is warmed up. Then we create a checkpoint, commit it, and echo some message. Let's test my script. I feel it so much more comfortable this way. I do not forget anything. Well, it obviously spams everything with this hash, but other than that, should be fine. Let's just try it. Oops. What? Docker commit. Sorry, what?
No, the exception.
Empty image.
We won't look at it. I really don't want to debug my bash right now. So we are close to an end, but I have to show you something else in Spring.
We have time, it's fine.
How much time do we have?
How much time do you need?
5 minutes?
You're fine.
Okay, cool. So let's say we have a completely, just in case. I showed you an example with web client, which is unmanaged by Spring. You will have to do the same thing for any connection you create or any file connection you create, like file handle. If you use gRPC and use gRPC and you create gRPC client manually, it's not managed by Spring, then you will have to implement resource. If you open a file and you write something in this file, you will have to implement resource and flush your stream, close your stream, then reopen it after checkpoint, and so on and so on. But let's say we do not have anything like that. Let's say we have a counter, where counter equals 0. Now we have a scheduled method. You know scheduled methods, right? It's just a nice way to force Spring do something periodically. Fixed rate equals 1, time unit equals second, please seconds, yes, something like that. Fun increase, come on. Increase, yes, thank you. And here we will do counter ++ and print our counter. We actually can probably do something what all Java developers hate and println counter ++. Should work, hopefully. We'll see. Also, we need something to test it. So we'll add one small endpoint that will return our counter. Idea, you're not as smart as you think. Okay, we don't need this URL, I think. Does it look good? Looks kind of fine. Since my bash script doesn't work, I will do everything manually again. Build, Docker build. Yep, almost there. Then Docker run. Let's look at logs just to be sure that it works. Seems like it's working. Counting something. Let's checkpoint it. And look into logs. Well, nothing interesting, just checkpoint created. Now we will commit it as usual and run with custom entry point. And this is something interesting. It starts from 21 and prints it very, very fast. Now let's stop it again. Even faster. Every time. It looks like the time somehow exists inside the entry point, but it's impossible. Who knows why? Why does it work this way?
Because of checkpoint.
Well, no. We already had this experiment with checkpoint and counter in our bash file.
I mean, somehow we share data of checkpoint.
No, we cannot modify data inside Docker image. Nothing changes the data. And still,
Timestamp at the last checkpoint was saved, and from there it's like running all the 1 second delays.
it is very close actually. It's hidden very deep inside Spring documentation. But when you use fixed rate and scheduled, It actually looks how much time passed since the last execution and then executes it so many times. So if you want to change it, then you will have to use something like cron, every second. And actually we can do every second this way, I think. Yeah, it's still everything second. And this way, your application with scheduled tasks will be executed the expected way. It's kind of mysterious. I mean, you should know it because it's, if you look into the documentation of Finkelshteyn, give me a sec, Finkelshteyn, there is nothing about it, like nothing. It just says that it will run it with a fixed period between invocations. I would expect that fixed period is counted as like some time should pass since last invocation, but no, it actually works completely different way. Fixed delay will always do. And it is so obscure. Why fixed delay that works another way than Finkelshteyn? And why in general there are two functions or two parameters, Finkelshteyn and fixed delay? Cannot explain it. Don't know. It's just how it is. Well, kinda. Let's summarize it quickly. Obviously, you already saw, CRaC allows us to start up any software almost instantly. Any software which is crackable. If your software, if you doesn't implement resource, then it will do an instant startup. But it will work, well, probably incorrectly. But it depends on your business logics, obviously. Maybe you need to preserve the state, like a checkpoint, and you do not need to recreate it in any way. Building Docker with CRaC is not simple, but doable. But you cannot do it in one like huge Docker image. You will have to perform some Docker magic, run your image with couple of capabilities, then checkpoint it somehow, maybe run your test suite before checkpoint, and then commit it, and then rerun the new image with a custom entry point, or create a new Docker file, which will stem from the committed image. You can also, you can not add capabilities, but you can run your container as a privileged. Your security will have even more questions. I do not recommend, because privileged means that you run your container with root privileges. It can do anything, like rmrf/ is totally available. Well, after that, checkpoint and commit. To support custom connections, custom file handles, and everything not managed by Spring, you have to implement your resources. For example, if you use a custom logger, not logback, you use log4j for some reason, it's not managed by Spring. You will have to write your custom resource that will close file handles open by log4j, and then it will restore them. And it is like a couple lines of code for each custom connection you have in your application. I can imagine a situation when there are a lot of them. Probably you are doing something in a not idiomatic Spring way, but you have right to do it. It's your code. Probably you'll have to write a little bit code, a little bit resource implementations. Thank you so much. Thank you for questions. This is all the ways to find me. Like currently, the Blue Sky is popular. I'm there too, in Twitter, Mastodon, LinkedIn, whatever. Now it's time for questions.
I have a question.
Yes.
It feels not really yet mature, polished, figured out. As you mentioned, there are a lot of limitations which kind of raise a lot of questions. And this is not the only way to speed up your Java startup.
Yeah.
Obviously, the elephant in the room is GraalVM.
I addressed it at the very beginning.
Which looks like a more canonical way to do it?
Yes. It's
so
native image is amazing.
Yeah. So when I will say, okay, you know what, I will go to this more obscure way instead.
When you need to improve your developer experience, the developer productivity, because with native image, it's actually not that easy to build a native image of your application, and it takes a lot of time. It takes minutes, tens of minutes, and so on. You can do it on your in your CI pipeline. You probably don't want to do it on your developer machine, because when you are building a native image, you cannot develop anymore. As we saw, creating a CRaC checkpoint is a matter of seconds. I would say 2, 3, 5 seconds. Maybe for huge application with huge heaps, it will be, I don't know, 10 seconds, 20 seconds. But hard drives are fast, relatively fast. Not as fast as your memory, but still fast. Especially if you're not using spinning drives, but NVMe's and so on. You will also go for CRaC when you somehow depend on architecture, for example. If you need, if you cannot build one native image and run it everywhere. You cannot do it with CRaC too, but imagine the huge matrix of native images you will have to build for all architectures you have. Let's say you build a software for your customers. Some of them use PowerPC, some of them use ARM, which is, well, PowerPC is almost improbable. ARM is totally probable. It will be there. Gravitons and so on. Some of them use usual Intels. Again, 3 checkpoints will cost you 12 seconds. 3 native images will take you a whole time. Also, you're running, when you run native image, it's a completely different thing than what you run from your IDE when you click this play button. It's something different. You cannot debug in the same way. You need custom ways to debug and so on. Here, it's the usual Java. It just starts up faster. Did I answer the question?
You did.
Thank you.
What are the top 2 scenarios when you think you needed a faster time?
Yeah.
Faster startup time?
Yep.
Because I think when we develop an application,
Yep.
You don't expect it to start every few minutes.
Yeah, this is fine. If you're fine with long startup, well, just don't do it. It's
The answer is cloud native, right? This is the scenario for which fast startups are a must.
Not only. Actually, Amazon has their own implementation of CRaC. It's called Snap Start. This is based on their own virtualization technology. The idea is the same. They implement CRaC in their CRaC support in their JDK, and this is what allows them to start up Lambdas faster. You cannot afford to spend 4 seconds on Lambda startup. It will just too expensive. Amazon recognizes it and addresses the issue. Yeah. Well, Lambda is not cloud native per se, as I understand it.
It's very cloud native.
Okay, cool.
It's not containers, but that's
Yes.
another flavor of cloud.
Yeah, but in containers too. Imagine you have to roll out your application to thousands of servers, and each of the servers can run many instances of your application.
And they also go up and down, right?
Yeah,
It's
constantly.
Auto-scaling back and forth.
Yes.
You shut pods down, the new pods are auto-healing, there is something happened. This is where it's really critical.
Yeah, I also wanted and forgot to show you. Yeah, the image, the snapshot of the whole application, in my case with this one controller, with this counter, takes 151 megabytes. It's not exactly small. It's still totally doable for your networks, like for networks and data centers where they have nice fiber and so on. Should be fast, less than a second to transfer it from machine to machine. Thank you for the question. Yes?
Thanks, Pasha. It's really helpful presentation. Couple questions. The first one, any recommendations for migration existing one project? What would you recommend? What you could highlight when trying to use in the existing one some of the applications?
Like, your question is, how do I migrate my existing application to CRaC?
Yeah.
Is it...
To use CRaC.
Yeah, to use CRaC. Is it Spring?
Let's assume yes.
Is it Spring 3.2 plus?
I improvise. I just trying to.
Yeah. So in general case, I cannot recommend anything. Like, if it's just a usual Java C application without any containers and so on, just go ahead and try. Try to create a CRaC snapshot. If it gives you an exception, then you know then you know that you have some open streams or resources. Yeah, it's something you can fix. If it works, it works. You're lucky. If it's Java EE, for example, I do not have any idea how to do it. I mean, Java EE doesn't support this technology. I'm not sure if they're interested. Luckily, Java EE is not Jakarta EE. Sorry, I lived 10 years ago. It seems. Yeah. So if your framework supports CRaC, you are good to go. If it doesn't, there are issues. You'll probably have, well, it's not that hard to implement support in any framework, actually. So you can send a pull request and say, you have these clients opening here and there. Let's make them implement resources, and they will close and open automatically on snapshots.
And the second one question, did you have a chance to support in production in kind of any problems with garbage collections?
It's the same Java. So it's not different at all, like at all. The garbage collector is the same. I do not clutter my examples here with JVM settings, but they work exactly the same way. You can pass all the garbage collector settings, all the memory settings, and so on. They all will be used the same way. It's just I just spun one -XX. You can pass more of them. It will work fine.
Funny story. When you present with Java, I'm working in parallel with other languages, Python and C# and question, why they are not supporting similar feature like Java? Why?
Well, you're asking why JVM is better than any virtual machine, just because a lot more human hours were put into it, and actually it's very high quality human hours. Python actually starts up fast, as well as JavaScript. Sometimes frameworks do not. But Python starts up fast. It's not an issue for your platform engineers. They see house checks passing like in a second after the startup.
Most interesting comparisons with .NET, especially.
.NET is for .NET it's very hard. They essentially do not have a virtual machine runtime. Well, they kind of have because they have a garbage collector. Well, it's very different. They have you have an out compiled application. It's not interpreted anymore. Your LR. What's bytecode? Your CLR almost doesn't exist. GC is there, yes. It's just a part of runtime, as well as coroutines, but anything else almost doesn't exist. It's just a native machine code. That's why you compile your C# application for each platform. .NET application for each platform. Also, again, we are solving the problem of fast startup. It doesn't exist for C#. Applications start up fast. It's out compiled. Well, if everything is good. Obviously, you can do a lot of lazy stuff, and the application will start up slow. You can do, I don't know, bin initialization, which will take 2 hours. It's up to you, but it's not what you usually do.
Thanks.
Thanks for questions. More questions? Then, thank you so much for coming.
All right, we stop the recording. We still have pizza, we still have swag.